Welcome. We will discuss today about another assumption of classical linear regression model that we made, that was the assumption of homoscedasticity. And if that assumption is violated, then we will say that the data set is basically suffering from heteroscedasticity problem, just the opposite of homoscedasticity. So, we will first try to understand what is heteroscedasticity, right. Okay. So, this is heteroscedasticity that we are going to discuss today. Scedasticity. What does it mean? So, let us try to understand what does heteroscedasticity mean. So, basically heteroscedasticity mean that the error variance of ui, if you recall, variance of ui, we assume that is constant. Okay, that was the assumption of classical linear regression model, and if this assumption is satisfied, then this is called homoscedasticity. Homoscedasticity. And homoscedasticity basically means a constant error variance. The other name of this is constant error variance. Constant error variance, right. Now, why this is called constant variance? See, here I have mentioned variance of ui, but here there is no I subscript. So, that means the ith person's error variance, jth person's error variance, kth person's error variance, all the error variances are sigma square, since there is no subscript like I, j and k after this sigma. That is why this is called homoscedasticity or constant error variance. But if the error variance looks like this, variance of ui equals to sigma square I, then this is called heteroscedasticity. That means, I am saying that the error variance for the ith individual is sigma square I, and then error variance for the jth individual is sigma square j. Okay. So, that means, when I am saying this is heteroscedasticity. So, if you are writing your model like this, y I for the ith person equals to alpha plus beta xi plus ui, and then you are saying that variance of ui equals to sigma square I, and then when you are writing the same equation for the jth person, that would become alpha plus beta xj plus uj, and then you say that variance of uj equals to sigma square j. Okay. And that is called actually heteroscedasticity. Heteroscedasticity. Okay, that is the meaning. Now, the question is, why does heteroscedasticity arises? Why does heteroscedasticity arise in the context of a data that you are going to estimate in using your econometric model, right? So, we will need to understand the reasons behind heteroscedasticity. Let us try to understand that, the reason behind heteroscedasticity. Okay. So, reasons for heteroscedasticity. We will try to understand the reasons for heteroscedasticity using a simple diagram. Suppose in the x axis I am measuring income and in the y axis I am measuring consumption, right, and let us say this is the regression line that you have estimated, this is the regression line. Okay. Now, for any this is let us say your yi and this is the xi. Now, for any given value of xi, let us say this is x1i, x1, this is the x1i, right, this value let us say this is x1. For any given value of x1, what you will have, this is let us say your yi hat, okay, yi hat equals to alpha hat plus beta hat xi. This is the line you have fitted. Okay. So, for any given value of x, you will see some observations on y will lie for some individual. That means, using this line regression line, you are basically trying to predict the individual's consumption. Okay. So, for a given value of x1, given value of x at the level say x1, what you will see that some individual's value will lie exactly on the line, that means you could exactly predict their consumption, while some individual will lie above the line, some individuals actual consumption will lie below the line. So, that means you will have a range like this. Okay. And we said what are these deviations? The deviations from your prediction is obviously error, right, because your predicted line says the actual predicted consumption should be like this, the model predicts the consumption here, but some observed consumption is actually above the line, some observed consumption is below the line. So, this is basically the error and this is the spread of your error term. Okay. This is the spread of your error term. Similarly, when you go to x2 level of income where x2 is actually greater than x1, then what you see that error variance looks like this. Okay. Error variance looks like this. Then again for x3 level of income, your error variance looks like this, right. That means what is happening, let us say this is u1, this is u2 and this is u3, spread of u1, u2 and u3. Now, what is the assumption we made? The assumption what we made that at different level of x, that means as income increases your error variance actually should not increase, that is the assumption we made. But here what is happening, as the individual's income increases from x1 to x2, x2 to x3, then what is happening, the error variance is actually increasing. Higher the income, higher is the error variance. That is why this type of pattern explains actually heteroscedasticity. But the question is why this error variance is increasing instead of being constant at different level of income. The reason is very simple. See, when the individual's income level at a very lower level, then you can actually predict very well about the consumption pattern of the individual. For example, let us say this x1 is basically the income of a day laborer whose income is, let us say, some 300 or 400 rupees per day. And what that individual day laborer will do with the 300 and 500? The day laborer will probably buy some 1 kg of rice, some half a liter of oil, some 200 gram of dal, so on and so forth. So, 400 rupees you can easily predict how the individual is going to spend. But as income increases, let us say from 300, now this individual's income is 30,000, sorry 3,000 per day, right, 3,000 per day. Now, with that 3,000, it is becoming very difficult to predict what that individual will do using the 3,000 rupees. Now, the question is why? Can you think of at higher level of income why people become more unpredictable? That is why you are committing so much of mistake, error variance is having larger spread. Okay? The reason is at higher level of income, people have higher degrees of freedom in their consumption pattern. So, that means with 3,000 rupees or 90,000 or 1 lakh income per month, I can buy a music system, I can buy rice, I can buy dal, I can buy a computer, or probably I can buy a new vehicle, so on and so forth. So, at higher level of income, the consumers, they enjoy a higher degrees of freedom to select from different consumption bundle, and as a result of which high income people become less predictable, and that is why this much of mistake, this much of error variance. Okay? That is why when you are estimating this type of consumption function, it would be highly unrealistic to assume that your error variance would be constant at different level of consumption. That is the reason. So, that means here in this consumption income relationship, we can say that at higher level of income, people become less predictable in their consumption. Because they enjoy higher degrees of freedom in their consumption. As a result of which variance of ui given x equals to x3 is much higher than variance of ui given x equals to x1. Okay? That is the reason. Alternatively, I can give another example to explain heteroscedasticity. I can give another example. Let us say this x axis I am measuring time, and in the y axis I am measuring error that you may commit in your typing. Suppose you are typing using a typewriter, I am noting down how much errors you are committing while typing. So, when you have just started your typing with very less amount of experience, let us say at the first hour, you may commit so many mistakes. So, that means your error variance would be like this. But as time goes on, this is t equals to t1. Then as time increases, what will happen? You will learn how to type better, and your error variance actually will come down. And when you have too much of experience, then you will have very less error. So, just opposite will happen in this case. So, that means variance of ui given t equals to t1 is much larger than variance of ui given t equals to t2, and then variance of ui t equals to t3. Whatever might be the case, whether it is increasing or decreasing does not matter. In this case, we see an increasing pattern of the error variance. In this case, we see a decreasing pattern of error variance, but whatever happens, error variance is not constant, that much we can say. And these are the reasons for error variance not to be constant, right. That means there might be heteroscedasticity problem. Now, the next question is, what are the consequences of the non-constant error variance? Consequences of heteroscedasticity. So, what will happen to unbiasedness? Unbiasedness, okay, unbiasedness is still maintained. What will happen to consistency? Consistency is still maintained, but the problem happens even in the context of heteroscedasticity also is variance of beta hat is no longer the minimum, okay. The moment you change the assumption regarding the variance of ui, then what you observe, that variance of beta hat is no longer the minimum. Minimum variance property is lost. And as variance get disturbed, again the standard error gets disturbed, and again your t or any other statistic based on that standard error, the t statistic get disturbed and your hypothesis testing become problematic. That means you are getting a t statistic which is not the original t statistic, rather that is disturbed because of the variance get disturbed in presence of heteroscedasticity. This is the problem, okay. This is the problem. Now the question is, how will you detect heteroscedasticity, right? How will you detect heteroscedasticity? So, there are different ways by which actually you can detect heteroscedasticity. So, I will write detection of heteroscedasticity. So, you can detect heteroscedasticity by some graphical measures. What does it mean? Graphical measure. graphical measure. The graphical measure says what you do after estimating your model, you put your ui hat square against your yi hat, and if you see some kind of pattern, either this type or let us say this type, ui hat square, then this is yi hat, or let us say this type, some kind of downward. So, both these conditions says this is heteroscedasticity, but if you plot your ui hat square like this, then you see that your this type. So, no pattern, this is upward sloping pattern, and but here there is no clear cut pattern that we can observe between ui hat and yi hat, then we say that this is homoscedasticity. Okay? Homoscedasticity. Now, the example we are thinking about income and consumption, we said that as income increases, error term is either error term increases. That means we were plotting the error variance against the explanatory variable, but here we are plotting error variance, that means ui hat square against yi hat. What is the reason? Because this yi hat basically captures the influence of all your explanatory variable. Otherwise, if you have multiple number of explanatory variable, you have to plot this ui hat square against each and every explanatory variable, isn't it? Suppose you have 5 explanatory variable in the model and you are not sure which particular variable is showing heteroscedasticity. So, what you have to do? You have to plot this ui hat square against each and every explanatory variable. To solve that problem, econometrician they suggest instead of plotting ui hat square on individual explanatory variables, what you do? You plot ui hat square against yi hat. Then you see whether you can observe some kind of pattern, okay, either upward sloping or downward sloping. If there is some kind of pattern, that is basically an evidence of heteroscedasticity. If there is no such pattern emerges, then we will say that the error variance is homoscedastic, right, homoscedastic. But these are all simple graphical measure, because sometimes from the pattern you may not even understand whether this is a pattern or not, right. So, this is some kind of initial kind of impression that you can formulate out of your data, but to detect heteroscedasticity, econometrician they have developed different statistical measures as well, sophisticated statistical measures, and we need to apply some of those measures to detect heteroscedasticity.